morning, students. Welcome to my channel, Lalit Sir. Today, we will understand Chapter 8 Motion Textbook Solution for Standard 9. So, let's start. Page 100. An object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. So, it can be yes. So we can say that an object with a zero displacement even when it has moved through a distance. Suppose you are moving on a park. Your move with a one path, and again if you reach to the same place, so your displacement will be zero. So our answer is yes, an object move through a distance, it have the displacement 0. So next question. Page 100. Question 2. A farmer moves along the boundary of a square field of a side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So here we can say the movement of the farmer. You can see here, this is the square boundary. So farmer move along this boundary. So what we will have to do first? First we have to check what is the total distance covered by the farmer in how many seconds, that is the time which is given to us. So first we also convert these 2 minutes 20 seconds in the seconds, because it has converted or covered entire distance, that is in 40 seconds. We also have to find total area that covered or total round which it has covered. So we will get the our answer. So we can say here, so sides of the square field, that is 10 meter, which is given. Okay. So perimetry, that is we know that the sum of the all side, that is multiply, or you can multiply with the 4 into side, or you can add 10 plus 10 plus 10 plus 10. So you get the 40 meter. So farmer moves along the boundary in 40 seconds. So that we can say that 40 seconds, in a 40 seconds, he covers 40 meter. So we can also understand that in 1 second, the distance covered by a farmer, it is the 1 meter. Okay. So if the distance covered by farmer in 1 second, that is the 1 meter. So the time which is given to us, that is a 2 minute 20 second. Here also we have to convert this 2 minutes 20 second in the second. So we'll get the 140 seconds. Okay. So now the distance covered by farmer in 140 seconds, that is 140 minutes, as we can say. Now we also have to find the round, total round, because we also need to find the displacement plus the place where he reached from the initial place to the last place where it is reached. So we need to find first the round, how many round it covers. So for that, the total distance and divide by perimetry, so we'll get the 3.5 rounds. Okay, now we got the 3.5 rounds. That means if it starts the farmer from the A, this is the one round, this is the second round, this is the third round. So we can say this is the 3 rounds completed by the farmer. But the 3.5, so again from the A to C. So this is the distance. So we can say the distance covered by farmer from A to C, we have to find the displacement. Now A to C we need to find. So what we can do? We will use here the Pythagoras theorem. Okay. So therefore the displacement which is given here, that is AC square is equal to AB square is equal plus BC square. That we know the Pythagoras theorem. Okay. So that is why we will get this 10 meter square plus 10 meter square in under root. So we will get, after solution this, we'll get 10 under root 2 meter. And we also know that the under root 2 value, the value of under root 2 is 1.414. So by multiplying this value of 1.414 with 10, we will get approximately 14.14 meter. So we can say that after 2 minutes 20 seconds, farmer will be equal to the 14.4 meter. Now he can say here if it is north, if it is south, if it is east, and if it is west. So we can say here from here to here. So we can say northeast from initial position. This is the initial position. From initial position, it will reach from the northeast. Okay. So you can take the screenshot of this answer. Next question on page number 102. Which of the following is true for the displacement? It cannot be 0. B. Its magnitude is greater than the distance traveled by the object. So let's check the answer. See, none of the statements is true for the displacement. Why? Because a displacement can be 0. Okay, suppose you are starting from this point. Your starting point is this. Though you go here, and after covering this much distance, again if you reach here, your displacement will be 0. So first statement is wrong for us, that it cannot be 0. It may be 0 in some cases also. And second questions, it is magnitude is greater than the distance traveled by the object. Now second statement is also false, because the displacement may be less than or equal to the distance traveled by the object. So next question, page 102. So we need to distinguish between speed and velocity. Now we know that what is speed and what is velocity. So speed is the distance traveled by an object in a given interval for time, where the velocity is the displacement of an object in a given interval for time. Speed is equal to distance upon time, whereas velocity is equal to displacement upon time. Speed is the scalar quantity, but it is only magnitude. You may understand that what is the scalar quantity. Scalar quantity means the only numericals. You will get the speed is equal to 4 meter per second, 20 meter per second, 100 meter per second, 100 meter per hour. You will get that is kilometer per hours also. And whereas the velocity will give you the quantity, that is with the direction. So velocity will give us the quantity with the direction. Now second question is, under what condition the magnitude of the average velocity of an object equal to its average speed? So the magnitude of average velocity of an object is equal to its average speed only when an object is moving in a straight line. So next question, page 102. What does the odometer of an automobile measures? The odometer of an automobile measures the distance covered by an automobile. Question 4. What does the path of an object look like when it is in uniform motion? An object having uniform motion has a straight line path. Question 5. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal traveled at the speed of light, that is 3 multiplied 10 meter per second. Now here we know that the speed is given to us, that is 3 multiplied 10 meter per seconds. Time is also given, that is 5 minutes. So we need to convert the 5 minute into the second. So we know that the 1 minute is equal to 60 seconds. So 5 minutes multiply 60, we will get 300 seconds. Okay. So we also know that the equation, that is speed is equal to distance upon time. So for this, we can calculate the distance, because we need the distance of the spaceship. So speed is given, that is 3 into 10, and the time is also given, that is 300 seconds. So what will the answer we will get? That is 9 multiplied 10 power 10 meter. So next question, page 103. When will you say a body is in uniform acceleration? Question 2. A non-uniform acceleration. As we know that a body is said to be in uniform acceleration if it travels in a straight line. So whenever any object or any body travels in a straight line, its velocity increase or decrease by, suppose velocity increase or decrease by equal interval of time, in an equal interval of time. So that is, we can say, the uniform acceleration. A body is said to be non-uniform acceleration if the rate of change of its velocity is not constant. Next question. A bus decreases its speed from 80 km per hour, 60 km per hour. Find the acceleration of the bus. So first what we can do, it is given here that bus decrease its speed from 80 km hour to 60 km hour in 5 seconds. Find the acceleration. Here first we convert this 80 km per hour into the meter per second. Why? Because the acceleration comes in the meter per second. That we know the unit of the acceleration, that is meter per second, the acceleration unit. Okay. Now, so 80 kilometer per hour. So what we'll have to do for the kilometer per hour, as we know, 1 hour is equal to 60 minutes. Okay. And kilometers, we have 1 kilometer is equal to 1000 meter, and 60 minutes multiply 60 seconds. So what we will get the answer, Whenever you have to convert the kilometer per hour into meter per second, always you multiply that 5 upon 18. Okay, because this is the 1000 equal to, and this is 3600 equal to. Okay, so if you cut short this one, you will get 5 upon 80. So after converting this kilometer per hour, what will get the initial speed of the bus, that is the starting speed, 80 kilometer per hour, that will get the 22.22 meter per second. Similarly, the final speed, because it is decreased from 80 to 60, the final speed we will get 16.66 meter per second. So time taken. Now find the acceleration of the bus. Time is given, that is 5 seconds. So the acceleration equation, we know that A is equal to V minus U upon T. So after putting all the digits according to that, you will get the answer. So next question, question 3. A train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. Now, you can say here the initial velocity of the train, that is 0. See, a train starting from the railway station. So that is why its initial velocity u is equal to 0. And moving with the uniform acceleration, final velocity, that is v, we have 40 km per hour. Again, we know that acceleration word comes, so we have to convert this 40 km hour into the meter per second. So for that, we will get 11.11 meter per second. Now, time taken, that is 10 minutes. It is also given in the minute. So we need to convert this 10 minutes into the seconds. So we will get 600 seconds. So the acceleration A is equal to V minus U upon T. So V is the final velocity, which is we got, we have 11.11 minus initial, that is starting, we have 0, and that divided by T, that is 600. So calculating with this, you will get your answer, that is 0.0185 meter per second. Okay, so move on. Next question. A bus starting from rest moves with a uniform acceleration of zero point 0.1 meter per second square for 2 minutes. So find the speed acquired and the distance traveled. So here we know that the initial speed of the bus, because it said this starting from the rest, so the initial speed of the bus u is equal to 0. Now acceleration is given, that is the 0.1 meter per second square. So the time taken t, which is also given 2 minutes. Now we convert this 2 minutes with the seconds, so we will get 120 seconds. So we know that v is equal to u plus at. Putting all the data in this equation, we will get our answer, that is, this is the answer we will get for the speed. Okay, v is equal to 12 meter per second. Now, second question is the distance traveled. So according to the third equation of the motion, we know that the v square minus u square is equal to 2as. Here s is the distance. This s is the distance. So putting all the data, you will get the distance traveled, that is 720 meter. The speed acquired by the bus that we do, that is 12 meter per second, and the distance traveled by the bus is 720 meter. So move on the next question. Page 110. A train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of 0.5 meter per second square. Find how far the train will go before it is brought to rest. So, here also we know that the initial speed of the train, that is given 90 km per hour. So again we need to convert it the meter per second. So we'll get 25 meter per second. So you can check here, 90 multiply with the 1000 and 600. As also I said, you can directly put here your 90 multiply 5 upon 18. Okay, 18 times 18, 5. So you will get 5 multiply 5, then 25 will be the answer. Okay, so 25 meter per second. Spinal speed of the train v, that is u, that is v is equal to 0, because finally the train comes to the rest, and the acceleration is given, that is 0.5, that is minus. Always acceleration comes in the minus because it goes back, that's why it is the minus 0.5 meter per second square. So the third equation of the motion that we know, that is v square is equal to u square plus 2as. So putting all data which we got right now, what we'll get? So we'll get the distance traveled by the train is 625 meter before it comes into the rest. So next question. A trolley, while going down an inclined plane, has an acceleration of 2 centimeters per second square. What will be its velocity 3 seconds after the start? Here also the same, initial velocity of the trolley is, that is 0, u is equal to 0, and acceleration which is given, that is 2 centimeter per second square, and time also given, that is 3 seconds. So the final velocity v is equal to u plus at, as we know, that is v is equal to u plus at. Therefore, the velocity of the train after 3 seconds, by putting all data, you will get 6 centimeter per second. So moving to the next question. Now A racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after start? So here the initial velocity of the car, which is given, that is 0, because it is said after start, so it has not started yet. So initial velocity is 0. Acceleration it is given to us, and that is 4 meter per second square. Now time t is taken, we have 10 seconds. So we know the distance equation, that is ut plus 1 half it is square. So therefore the distance covered by car in 10 seconds, we will get 400 meter. Next question. A stone is thrown in a vertically upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction, what will be the height attained by the stone, and how much the time will it takes to reach there? Given initial velocity of a stone, that is we have u is equal to 5 meter per second because it's the starting. Now downward of a negative acceleration, because it comes downside, so that is also in a minus, so that is minus 10 meter per second. We know that equation 2as is equal to v square minus u square. So height s is equal to v square minus u square upon 2a. Okay, that is here v square minus u square upon 2a. So we will get the distance s. So here it will get the 1.225 meter. So now we also know that the final velocity v is equal to u plus at. So time t, it is also we need to find. So t is equal to v minus u upon a. Therefore time taken by to attain the height, that is 0.5 second. So these all questions answer, you can take the screenshot or you can note down in your notebook. We will meet with the next video. Thank you.